In the previous video, we went over how the density function of a function of a random variable is related to the density function of the random variable. And in this video, we're going to apply that general result to the case of the normal distribution. So if x is a random variable, with density function f of x, which is 1 over the square root of 2 pi times e to the minus x squared over 2. So one can check that when you integrate from minus infinity to infinity, that this is equal to 1. There's a nice kind of polar coordinates proof of this. Okay. So if this density function is the density function of x, then we say that x has the standard normal distribution. And we let y equal sigma x plus mu, where sigma is positive. And the question is, what's the density function of y? Well, notice that y equals r of x, where r of little x is sigma x plus mu. And so r has inverse. S of y equals y minus mu over sigma. And by the result that we have found, we know that y has density g of y, which is f of s of y times s prime of y. Well, s of y, we know, is y minus mu over sigma, and then s prime of y is 1 over sigma. And so this is equal to 1 over sigma times, now we plug in y minus mu over sigma into the function f. So we get 1 over square root of 2 pi times e to the minus y minus mu over sigma squared over 2. And this we can rewrite as 1 over the square root of 2 pi sigma squared, because sigma is positive, e to the minus y minus mu squared over 2 sigma squared. So that's the density function, okay, of capital Y. And we say that, so we have this, and we say that capital Y is, or it has a normal distribution with parameters mu and sigma squared. And it turns out that mu is the mean of y and sigma squared is the variance of y. So that's the mean of y, or the expectation of y, and that's the variance of y. So sigma is the standard deviation of y. we can go backwards. So notice, just one final remark is that if y has a normal distribution, which I'll write like this, n of mu sigma squared, okay, then if we define x to be y minus mu over sigma, then x has a normal distribution with mean 0 and variance 1. So this is the standard normal distribution. So we would write x with this tilde, normal 0, 1. Okay, so the point is that the normal distribution with this density function with the mu and the sigma squared is just what you get when you start with the standard normal distribution and then apply the function sigma x plus mu to it. So that's the connection between the normal distributions.